This lesson is evaluating definite integrals. This is the function we've been working with. We're going to make this a little simpler today. We're going to say that the integral from a to b of f of x dx is equal to the antiderivative of f of b minus the antiderivative of f of a. This is the capital F of x is the antiderivative of little f of x. This is the evaluation theorem, and the evaluation theorem makes it pretty simple to evaluate some integrals. When applying the evaluation theorem, we use the notation from a to b to mean f of b minus f of a. Other common notations are, instead of a bracket, we'll just use a straight line. Some people bracket in both ends, and you might see me mix mine a little bit. I don't know what's going on with my formatting here, but somehow my points of integration are ended up over the top of my integrand integral symbol, and it's just not very nice. But that's the integral from 1 to 3 e to the x dx. We know the antiderivative of e to the x is e to the x, and so we just need to evaluate this from 1 to 3. So we're going to take, according to the theorem, we're going to take e to the 3 minus e to the 1. Well, we can't really simplify that without going into a big decimal, so we'll just say that's e to the 3 minus e. Here's another one. You can try this. We're going to try to find the area under the curve, cosine curve from 0 to pi over 2. See if you can at least set up the integral, and if you can, solve that thing. The integral would go from 0 to pi over 2 cosine x dx. The antiderivative of cosine is sine x, and we're evaluating from 0 to pi over 2. So we're going to take sine of pi over 2 minus sine of 0. That's 1 minus 0, or 1. So the area under that curve from 0 to pi over 2 is 1. Try this one. Evaluate the integral from 0 to 2 of that polynomial. Well, first we'll take the antiderivative, and then we'll evaluate it from 0 to 2. So plugging in 2, we get 16 minus 8 plus 10, and plugging in 0, we get just plain old 0. So the whole thing just evaluates to 18. Try this one. Integrating from -2 to -1. Take the antiderivative, plug in -1, minus, plug in -2, and then just evaluate. We get down to -63/4. That's our target for today. I'll see you in class.